20-1s, Chapter 8 and 9. Well, Chapter 8 and 9, Chapter 8's already done, 2 lessons. Really nothing new, it's just the fact that we had to take the information for solving linear systems, which we did in grade 10, or in 10C, and incorporate the quadratics into it, and then do some word problems. That's all Chapter 8 was. Chapter 9 now, we're going to deal with inequalities. Well, inequalities, this chapter is, again, one of those different chapters. Not a lot of big calculations, it's just being able to apply information. So the big thing is all the work that we've done this year has been with equation signs. And not inequalities, but equations. So we had all kinds of different stuff. 4x squared minus 7x plus 2 equals 0. And we solved it. We knew that x worked out to be possible values. Quadratic, probably 2 answers. X was something. Well, the big difference with an inequality is that I could have this same kind of information, but now I say, instead of equaling, we're saying that this equation or expression has to be greater than 0. Or less than 0, sorry. Or that particular expression could be greater than and equal to 0. So now we have to solve not for specifics equal to something, but we need to come up with some values so that this left side is less than 0. Well, that means there's going to be all kinds of possible answers, because it doesn't have to be one specific thing. It doesn't have to equal 0. It has to be less than 0. So there's all kinds of things that I could put in there to make it less than 0. So an inequality, instead of coming up with very specific answers, we come up with something that looks like a specific answer, but there's lots of possibilities for it. The other thing about this particular chapter that's a little goofy is we're going to talk in terms of situations that are 1 variable and situations that are 2 variable. 1 variable, is a linear. When I have 3x minus 7 is greater than 2. 1 variable, we're dealing with an x. Now, it could be a quadratic. 4x squared minus 2x is less than or equal to 5. Okay, but we're still talking about just x. There's no y. So there will be a process for dealing with single variable situations and inequalities. But we're also going to deal with 2 variables, which isn't a lot different. We could have 3x minus 7 minus 2 is greater than y. Well, all of a sudden, now we're dealing linear still because there's no squared, but now we have 2 variables, an x and a y. We could have the same thing, 4x squared minus 2x in a quadratic. Minus 5 is less than or equal to y. Well, now we're dealing with 2 variables, so it's going to be a little bit different process. So those are the 2 situations. The calculations aren't new. It's just applying the information that we have in what we're trying to work with. Got to be attentive. Got to do the practice to get through it. So here we go. Let's start by solving single variable linear inequalities. So no squareds to start with. Page 12 is where we're going to start. Now, what's important is that this first bit is grade 9. You learned about single variable linear inequalities in grade 9. So this is not new. Going to go through this quite quickly. When we're solving an inequality, what's nice? It's the exact same process as equations. We essentially are going to do all the same steps. We would multiply to get rid of brackets, combine like terms, move your variables to one side, isolate the variable. Solving doesn't change except if you multiply or divide both sides of the equation by a negative value, you flip the inequality. So that's the big difference in solving. We're going to do all the same steps, but if, and this will almost always happen as a last step, if you multiply or divide both sides by a negative, the inequality has to flip. So here's the same question we're going to do twice. We're going to solve it, and we're going to move the x's to the right side the first time, and we're going to move x's to the left side the second time. So here we go. 3x minus 16 is less than 5x plus 2. We need to figure out what values for x will make the left side not equal to the right side, but less than the right side. There's values that will always make this 3x minus 16 smaller than the right side 5x plus 2. So here we go. Let's solve. Nothing changes. Going to move the 3x over to the right. If it's a 3x, I'm going to subtract 3x, subtract 3x. We're left with a negative 16. Keep the inequality sign. 5x minus 3x gives us 2x plus 2. Now, if I move my x to the right side, I have students that don't like x's on the right side. Doesn't matter. If that's where you're starting your solving, leave it there till the end, and we'll talk about it then. We want to get x by itself, so we're going to subtract 2. Subtract 2. We have negative 8 is less than 2x. Finish the solving. How do we get x by itself? We divide by 2. Divide by 2. Now, we look back at that rule, multiply, divide both sides. We're multiplying by a positive 2, so it doesn't matter. Everything stays the same. Cancels out. Negative 8 divided by 2 is negative 4. Again, don't move your x to the other side. Finish solving. If your x is on the right side, keep it on the right side till the end. What this inequality is telling us is that the negative 4 is less than x. If you don't like the x on the right side, but that's where you were solving, wait till you're finished. Now switch them. And remember, the alligator always eats the big number. So if x is being eaten here, if I'm going to switch the x and the negative 4 around, make sure the inequality switches so that the alligator is eating the x in both cases. Same answer, different way to show it. So what this is saying is that x is greater than negative 4. Well, if x is greater than negative 4, we have a whole bunch of possibilities. What does x greater than negative 4 mean? Well, that means negative 3 could be an answer because negative 3 is bigger than negative 4. Negative 2 is bigger than negative 4. Negative 1 is bigger than negative 4. And we keep going. So we end up with a whole bunch of values for x because it's an inequality. They're solving. Now, let's solve the exact same equation, but instead of moving the 3x over to the right, let's move the 5x over to the left. And if we're going to do that, here we go. Subtract 5x, subtract 5x. That leaves us with a negative 2x minus 16 less than 2. We have to be aware if we multiply or divide both sides by the negative. Haven't done that. To get x by itself, I'm going to add 16. Add 16. We now have a negative 2x less than 8. Negative 2x less than 8. Divide by negative 2 on both sides. divide or multiply both sides by a negative, flip the inequality. So we still have an x, we still get our -4, but our less than sign, because we divided both sides by the negative, flips to become a greater than. And our answer is x greater than -4. Look at that. Same answer, two different ways. X is bigger than -4, so x could be -3, -2, -1, and so on. So you saw this back in junior high. Quick review, single variable linear inequality solving. The one rule you have to be careful of. Now, because there's multiple situations, we're going to see with inequalities, we do a lot of graphing. Because if I were to graph an equation, if I did an equation, I got x equals 10, and it said graph it. Okay, 9, 10, 11, x is 10. That graph is really exciting. It's 10. I mean, an equation gives us one answer. There's no need to graph. However, let's take a look and say that x is greater than -9. Well, if x is greater than -9, well, what do we end up with? So I want to graph this. However, I also want to go back to the examples I just did. Oh my goodness. Take a look at these examples. It just dawned on me I made total boneheads again. Oh, it's getting late in the year. -16 minus 2 is not -8, it's a -18. So -18 divided by 2 is -9. Hoi, hoi, hoi. X is greater than -9. Sorry about that. And even over here, I made the exact same mistake because I was just basing it on what I had. 2 plus 16 is 18. Now, we did divide both sides by the negative, so we get -9. X is greater than -9, but oi, oi, oi. I apologize. All of a sudden, boneheads galore. So with that being said, x is greater than -9. What would be a solution? What values are bigger than -9? Well, x could be -8, -7, -6, and so on, all the way up to positive infinity. Oh, sorry about that. Let us continue now with looking at the graphing. So now we want to graph x greater than -9 because it's more than one answer. So in order to do a graph, it's linear. So we just want to put it onto a line graph and identify the points. We want x to be bigger than -9. Now, everything we do, we're thinking in terms of x being a member of the real numbers, positive, negatives, and fractions. What's the first x value bigger than -9? Well, that would be not -8, but technically -8.999999 is the first value bigger than -9. Then we could think -8, -7, and so on. So how would we graph that? Well, what we would need to do, I like to put -9, -10, -8, maybe a -7 on there. So what this is saying is we want the values from -9 and bigger, but we want to start at -8.99. Because it doesn't include the 9, we circle it and leave it open. It's kind of like you're protecting the -9, but then you say, we want every other value all the way up forever to positive infinity. Don't include -9, but include everything else. You'll see it with the highlighted line. Sometimes you'll see it with an arrow like that. Either way is acceptable, but that's showing we want the values bigger than -9, but the open circle on -9 says don't include it. So how that could change a little bit is if we wanted the x values greater than or equal to -9. Well, in this case, it's almost the same thing, but because of that equal to, we want -9 and everything bigger, -8, -7, and so on. So this time at -9, we would want to dot, highlight it in. Open dot, don't include it. Covered in dot, we want -9 and everything else going forward. And the solid line means we want all the bits and pieces between all the holes. There's how we graph single variable linear equations. Really quick, turn off the video, give this one a try. Graph 12 greater than or equal to x. Well, in this case, if you don't like x on the right side, it confuses some people. It's okay to rewrite it as long as you're consistent. Here, the 12 is bigger than x, so just make sure we write it as such. They mean the same thing. So to graph it, 12's in the middle, give me a couple points higher, maybe a couple points lower. We want the x values less than or equal to 12. Well, we want to include 12 in this case, so we can dot 12. And we want x to be less. So 11 is less than 12. 10 is less than 12, and so on. So start at -12 and include it, and then make sure everything smaller is highlighted to say to include it. So that's single variable linear inequalities. You've seen it in grade 9. Well, here's the big change. Page 18, we're going to do the single variable before any double variable, so we're skipping a few pages we will review later. But we now want to go to single variable quadratic inequalities. Makes it a little more complicated. So if we consider, to start with, the equation, not an inequality, now we have an equation where x squared plus 6x minus 7 equals 0. Well, in order to come up with the answer there, what do we do with an inequality? Or sorry, a quadratic equation? Well, we could factor it. If I factor this, what do we have? We have positive 7, x minus 1 equals 0, because 7 and -1 is -7. 7 and -1 adds to 6. So in this case, x could be -7 and x could be 1. Now those 2 points are important because now we could get a visual of this. If I have a visual of a quadratic on the graph now, we have x at -7 and we have an x value at 1. So there's our intercepts. And the other key to this is because it's a positive x squared, if I were to do the vertex form, I'd be factoring out a positive 1. We know that it opens up. So we know that our quadratic looks something like that with intercepts of -7 and 1. And the intercepts are what's key here. So that's the equation. Now, when we look at the inequality possibilities, again, we don't want just individual values. This first one tells us we want the part of the graph that's greater than 0. So this means we want the positive portion of the graph. Well, when I take a look at this graph that I've quickly sketched, where is the positive portion of the graph? That's what we need to identify. Well, the positive portion of the graph is the part that's above the x-axis. And so that identifying what part of the graph is positive can help us come up with a solution. In this first case, what part of the graph is greater than 0? Well, greater than 0 occurs from -7 down. For the x values less than -7, the graph is positive there. So x is less than -7. That's where our parabola is positive. Now the second part, we could have also the positive part of this graph occurs here, and that occurs for the x values that are greater than 1. So x less than -7 and x greater than 1. These are the values for x. That's what we're trying to do. We're trying to solve the inequality, identify the x values that give us a positive graph. Less than -7, bigger than 1, give us the positive portion of the graph. Now the second part to that is the second inequality. The second inequality wants to know what part of the parabola is less than 0. So where is the parabola negative? Well, the parabola is negative below the x-axis. That's the part of the parabola that's negative. So what are the, because we're trying to find x values, what are the x values that give us a negative portion of the graph? Well, that negative part of the graph occurs from -7 down and from 1 up. So that's the portion of the graph we want. And how do we write that? Well, it's not a lot different than piecewise. What do we want? We want -7 to be less than x, and we want x to be less than 1. So we want the x values bigger than -7, but we want the x values to be less than 1. There's the solution for that inequality. So you have to try to visualize the quadratic as a parabola and identify, like in piecewise, what are the x values that give us that. Now the last two aren't a lot different except we have equal to. So again, we want to know what part of the graph is greater than or equal to 0. So the positive and 0. So it's not a lot different than what we started with. There's the positive portions, but this time because it's equal, it's going to be the exact same thing as the first one we looked at, but now we want the x values less than or equal to -7. And the x values greater than or equal to 1. -7 and less gives us positive. 1 and greater gives us positive. So we have to include it. It's the only difference. What part for this one is less than or equal to 0? Well, again, less than 0 is from -7 to 1, which we just talked about is -7 less than or equal to x less than or equal to 1. So that's what we're trying to do with single variable quadratic inequalities. Think of the graph and identify the parts that are positive or negative according to the inequality. So this is a better example of what you'll have. You won't have to do all four. Here, this question now says solve x squared plus 6x greater than or equal to 7. So the first thing we want to do is we want to find the zeros. X squared plus 6x, bring the 7 over, -7 equals 0. To find zeros, I think of it as an equation because that's what the zeros are, answers for an equation. Well, this is x minus 7, sorry, plus 7, x minus 1 equals 0. So we had just done this one, so it's really no different. But we're not looking for all four, we're just looking for that particular answer. So if I think of a line, we know we're at -7 and we know we're at 1. And we know because it's a positive x squared, we open up. So there's our graph. Now before we identified all four, but a question is going to ask for just the single inequality? Well, I solved for my x's, but I could put my sign back in. We wanted x squared plus 6x minus 7 to be greater than or equal to 0. Well, what does the greater than equal to 0 tell us? It tells us we want the positive parts of the graph. And we just walked through that for this situation. Here's the positive parts of the graph. What x values give us that? And we're including 0, 1 and up, -7 and down. So our answer would be x is less than or equal to -7, and x is greater than or equal to 1. And there's solving the inequality, because we're only looking for one of those situations, not the 4 that I showed you right off the bat to try to explain to you what's going on. Let's try another one there. Solve x squared minus 2x is less than or equal to 24. Okay, well, here we go. Little bit different twist on this one too. We'll add to it, just show you something. X squared minus 2x, bring the 24 over, less than 0. So now I want to solve. Multiply to -24, add to -2, x minus 6 times x plus 4 is less than 0. So our x's could be, if that's 0, x is 6, and if this was 0, x is -4. We have 6 and -4. So this is also referred to as interval analysis. Having the visual of it is helpful, but I'll show you exactly what interval analysis talks about. There's 6, there's -4. Again, x squared is positive, so we know that it opens up. So it would be a quadratic kind of like this. Doesn't have to be perfect because we're looking for the x values. Now this particular graph, I'm not going to look at the graph right now. Interval analysis, what it does is you choose an extra point in each section. Well, here, actually this isn't, I mixed this up. Let's go so it's a proper number line. So this would be -4 on the left and 6 on the right. Sorry about that. So we have -4 and 6. So what value is in this bottom portion? Well, we could just pick something nice and easy to work with. I'm going to put -10. In the middle, well, what's nice is 0 falls in there. And up here, we would have +10 on the number line. Well, interval analysis, what you can do is you can take what you have and put the value you want to analyze into that. -10 minus 6 times -10 plus 4. All I've done is I've taken my factored form and thrown in my test point. Well, -10 minus 6, that's a negative value. -10 plus 4, that's a negative value. And what's a negative times a negative? It's a positive. So in this section of the graph, we see that it's positive. And we can see that by how we would sketch the graph. So if you didn't actually want to look at what the sketch of the graph was like, you can pick a point within that section and just throw it in and see whether it's positive or negative. And we see that it is positive. In the middle portion here, well, I'm going to use 0 now. So I take 0 minus 6 times 0 plus 4 as a test, 0 being put into my factored form. Or I could put it into the actual quadratic, but it's easier in that form. 0 minus 6 would be negative. 0 plus 4 would be positive. Negative times a positive is negative. So in this middle section, we have the negative part of the graph, which is what we have. So it works. And in the last section on the right, well, we should be able to predict what's going to happen. It should be positive. Let's put in our test point of 10. 10 minus 6 times 10 plus 4. 10 minus 6 is positive. 10 plus 4 is positive. So we get a positive section from 6 and up. So if you don't want to think in terms of the graph and visually see it, we can put in a test point to see what it finishes as. So now we have this key part here. Our quadratic parabola needs to be less than 0 or negative. That's what our inequality tells us. Well, we can see by our test points that we want to know where our quadratic is negative, and that happens between -4 and 6, because that's what our test point showed us. The outside parts were positive, but this question is asking where is the quadratic less than 0 or negative. So now we can identify that. The answer would be the points from -4 to 6. So what points are that? It doesn't include it, so we would want -4 less than x less than 6. And there's our answer by using an interval test point. Some people like to just use test points. Some people like to sort of visualize what the graph's going to be and see, oh, here's where it's negative below, here's where it's positive above, and then figure out their x values from there. Last one, page 20. Let's give this one a try. On page 20, this one's going to be a little trickier. I'm sorry, but you got to do some thinking. So again, we have x squared minus 4x. Bring my 10 over, greater than 0. What multiplies to -10 but adds to -4? Nothing. That's frustrating. So what do we have to do? Well, we have to get those 0 values. So if we can't factor it, we have to use the quadratic formula. -b, so a -4, plus or minus b squared, -4 squared, subtract 4 times a, which is 1, times c, which is -10, all over 2 times the a value, which is 1. This gives us x equal to 4 plus or minus root 56 over 2. Well, because we're trying to figure out our zeros, we need to try to be as specific as possible. We need to be, depends on the situation, whether it asks for rounded or exacts. You have to be able to do both. Our 56 could be split into, if we did that, 4 times 14. So the 4 will root out. So we could have 4 plus or minus 2 root 14 over 2, which becomes 2 will cancel with all of these and leave us with 2 plus or minus root 14. So that means our 2 interval points, one of them is at 2 plus root 14, and the other one is at 2 minus root 14. Now, if you did those values, you'd have -1.74, and you would have 5.74. So it depends upon whether a question asks for exact values or rounded. It's the same idea though. We find those zeros. So now we can check the intervals. Now it's a little harder because we don't have a factored form to plug into, but what intervals could we choose? What numbers could we maybe put in here? Well, we could go to a -2. we could test with 0, and we could test with 6. So those are the points that I'll check with. So in that case, I now, because I don't have a factored form, again, I just need it to be positive, negative, not exact. We would have negative 2 squared minus 4 times negative 2 minus 10. So what would we end up with? 4 plus 8 minus 10. We get a positive in this section. So we know this area here are positive values. So I now want to check my middle interval. My middle interval, I'm using 0. 0 squared minus 4 times 0 minus 10. 0 minus 0 minus 10. Well, we know that's going to be negative. So we know that our middle interval is negative. And finish that with this last interval section using the 6. 6 squared minus 4 times 6 minus 10. 36 minus 24 minus 10 leaves us with positive. So there you go. Not a surprise in terms of the fact that we do, if we wanted to think of this as a parabola, it's positive till it's at the x-intercept, drops into the negative, next x-intercept goes up to positive. Positive in this section, positive in this section, negative through the middle. Whether we look at it as a sketch or use the intervals, either way works. But we have to now write the solution. Don't forget about that. We want to know the parabola is greater than 0. So where is the parabola positive? Well, the parabola is positive from this value and down. The parabola is also positive from this value and up. So our solution would be for the x values less than 2 minus root 14, and also for the values greater than 2 plus root 14. Not equal to, because we're not equal to there. There's our answer. Little different, manageable, but again, a little quirky. There, ladies and gentlemen, is your assignment. Textbook, page 484, 485. Having the ability to quickly sketch your lines and figure out your intervals. Understand, are we looking for the parts of the parabola that are positive or negative, and then writing the domain essentially of those. Little different. Give it a practice and have fun with it.